Good morning everyone. So previously in our chapter cement industries we saw introduction about cement, its types, and then manufacturing of Portland cement. Now today we will see manufacturing of lime, the main raw material for cement, and it is calcium oxide CaO. So these are some physical properties: its molecular weight, melting point, boiling point, density as given. Next we have a hydrated or hydrous form of lime known as hydrated or slaked lime, which is CaOH twice. Its chemical formula, and its physical properties are molecular weight, density, and decomposition to CaO takes place at 580 degree Celsius. Next we have grades, the commercial grades in which lime is available. So commercial is not 100% lime or 100% CaOH twice, but it is mixed with magnesium and its oxides. And then again, quick lime has more calcium as compared to slaked lime or hydrated lime. So it has more than 90% purity of CaO and low quantity of magnesium oxide. Then hydraulic lime has as compared to quick lime, magnesium oxide is more in percentage. Then next is consumption pattern. So it is used as a basic flux in the manufacturing of steel. Silicon dioxide is a common impurity in iron ore which cannot be melted unless it combines with other substances first to convert it into more fluid like lava, which is known as slag. And silicon dioxide being Lewis acid, and it reacts with Lewis base lime. So in manufacturing of this steel, and to melt it we use lime with silicon dioxide. The molten silicate slag is less dense than the molten iron and collects at the top of the reactor, which can then be removed. Next is methods of production of lime. So these are the two classification processes. Calcining limestone to yield quicklime and hydration of quicklime. We will be seeing process flow diagram for this quicklime process. And the quantitative requirements are limestone, pure limestone, and coal. So the plant capacity of this typical quantities is 100 to 500 tons per day. We will see or understand the manufacturing with the help of process flow diagram. So this is the process flow diagram for manufacturing lime using quicklime process. So we'll start with limestone. Limestone is quarried means it is mixed into and put on conveyors feeding the mills into the crushing unit. This is the crushing unit and mill. Limestone of several sizes is produced with jaw or gyratory crushers used for hard rock breaking of hard rocks, and hammer or roll mills used for soft rock. So depending upon our type of limestone. And also it depends on the type of calciner that we are using. So most commonly used kiln is this type of vertical shaft kiln. So this vertical shaft kiln is about 3 to 8 meters in diameter, and height Height ranges from 9 or 10 to 25 meters high, and this shows that this kiln is lined using refractory bricks, and it is covered with steel sheet outside for strength and prevention of gas leakage. Also, because it is very exothermic or hot in nature. Now, operation which is being carried out is of two types: unmixed or mixed. So unmixed is when coal is fired in separate combustion chamber and flue gases supply heat of decomposition. As in this case, flue gases are supplying the heat of decomposition. Then another method is mixed, where coal is mixed with limestone lump, but coal ash is added to the product. So when limestone is being entered as raw material over here, at that point only coal is mixed. Next, feed is entered from top of furnace, where combustion gas preheats the stone. As it is gradually moving down, it is sliding down the this vertical shaft into the calciner here in second zone. First is the preheated zone and then calcining zone. This section of the shaft operates at around 1000 to 1100 degrees Celsius, and CaCO3 here decomposition of CaCO3, that is it is taking place at around 800 to 898, so near about 900 degrees Celsius. Then further the lime lump moves to the cooling section, where heat exchange occurs between secondary air and hot lime particles, which is this section, this last cooling section. Further, after cooling in a conveyor, lime is either packed as lump lime or crushed and screened into pulverized lime, depending upon what grade of lime we whatever is the need of the consumer, or whatever is the requirement. So if lump quicklime is the product, the process stops over here. But if you want a different grade, then it is sent to tube mill grinding, then into pug mill, where powdered quicklime is obtained after tube mill grinding. And even then, if that is our requirement, then powdered quicklime is obtained. Even after that, if slaked lime or hydrated lime is our desired product, then it is forwarded into pug mill, and water steam is added, and with the help of screen classifier, that is with a classifier of a specific mesh size is used, and screen of specific mesh size is used, and slaked lime is obtained. So this was manufacturing quicklime process for manufacturing of lime. We saw different grades of lime can be obtained from this process. Now, as we can see in this process description, hydrated lime process and this quicklime process both are described in a single flow sheet. So this flow sheet is also applicable for hydrated lime, as we saw from this figure, that quicklime lump is crushed into 2 centimeter or less, and it's added along with water or steam into a vertical cylinder pug mill containing 18 to 24 extended horizontal arms. So this pug mill, it is a specification of this pug mill, which contains 18 to 24 extended horizontal arms. Operation here is usually continuous, and product from complete reaction is light, dry slaked lime which is classified by screen or end separators to remove any leftover which is not completely burned lime that did not hydrate. So the finely divided product is then packed and it is taken for shipping or storage. And steam under pressure is used here, and that is done to increase the speed or rapidly convert MgO where lime is used. Over here we are talking about this water steam that we are entering or introducing into pug mill. And this hydrated lime process, if we are not stopping at lump grade, so the capacity of the slaked lime or hydrated lime is with 1 ton of calcium hydroxide, the plant capacities are 50 to 100 tons per day. So this was the hydrated lime process as this. Next is major engineering problems in this process. So the first is the choice of kiln. Selection of proper kiln is very important. So rotary kilns are favored for large production rates for quality product, and the degree of calcining is more readily controlled. So for example, we can say that overburdened lime requires higher temperature residence time to provide partially fused unreactive CaO MgO refractory cells, and this degree of overburning is usually more easily controlled in this rotary type of kilns. And vertical kilns, that the one we are using here, this type of vertical kiln are best adapted for smaller capacity operations. So for example, in soda ash industry, this type of vertical shaft kiln can be used. Also of these different types of kiln, for 70% of the total production of lime in India, more than 70% is produced using rotary type of kilns. Next problem is heat transfer operation. Optimization of particle size, residence time, gas temperature, velocity profile, and heat economy in kilns is a major issue which needs to be controlled during lime manufacturing process. Economics of lime industry. So lime production is very dependent on the steel industry, which in turn fluctuates directly with automobile and housing demand. So these are datas where automobile was not a rage as it is now. So for today we can say that steel industry is booming, and it will be like this for many years to come. So demand of lime is not going to decrease in a way. Lime being an energy intensive chemical, because of high temperature required to make it from limestone, fluctuates more with energy prices than other inorganic chemicals. Yes, so because of the flue gases that we have to give it as energy, it is not a renewable source of energy. So again, it becomes a question, or it becomes an issue, and its prices are highly dependent on the prices of fuels as well. So these are the data from 1970 to 75. The price more than doubled. So these are international price. So we can see the price is doubled from $12 to $28 per ton, mainly because of the oil embargo increased energy cost. So in international oil market, because of increase in oil oils prices, the prices also doubled for lime from $12 per ton to $28 per ton, that which is more than double. As of 1992, the price was $49 per ton. So these are the old data, and now it is even more. Thus we can say, because of higher use of renewable type of energy, its price is increasing. If any non-renewable type of energy source is discovered for lime manufacturing, then it will solve a lot of issues for its manufacturing. So this was about lime and its production.